All right, lesson 8.2 is finding angles given an area. So we're doing the same formula or using the same formula, but this time we're finding the angles when we know the area. So let's write our area formula for a triangle, oblique triangle, meaning it does not have a right angle in it, is 1/2 times side A times side B times sine of angle C. Okay, so in this picture, I'm going to replace the area with 1,256. Sides A and B, doesn't matter which one you put where, but are the 89 and 51. Times sine of C, I do not know the angle, so I'll leave it C. So what I want to do here is isolate my sine of C by figuring out what this number would be. So 89 times 51, half of that, I'm going to divide it by 2, is that. 2,269.5 sine of C. And then I'm going to divide away that number. And you should get a weird decimal. So I'll put a couple of the digits. But remember, when we are trying to find the angle, to get rid of the sign, we're going to inverse sine of this number, and that will cancel that out and give us the angle. So that's second sine, putting second answer, and it's in round to the nearest tenth, so that would be 33.6 degrees. Okay. Number 2 is the area of a parallelogram. It's 10. Shows us the side lengths to the nearest tenth. Find the measure of the obtuse angle of the parallelogram. So there's going to be a little extra step to this. Okay, so area of a parallelogram is taking out the 1/2 because we have two triangles here. It's just A, side A times side B times sine of angle C. Okay, so then my area is 10. So here's my angle. The two sides I'm going to need are here and here. I got 4.8 times 3.9 times sine of C. And so what I'm really doing is taking 10 divided by these two numbers. Okay, get that weird decimal. And then I want to inverse sine. And you get the angle to be 32.3 degrees. But I want you to think about this. Going back to talking about finding angles, this will always find us the reference angle. So we have an angle here in quadrant 1 that's about 32.3 degrees. And this was sine. Sine was a positive measurement. So where else is sine positive? In quadrant 2. We need a reference angle of 32.3 degrees. And so how do we find that? Remember, to find it, we take 180 minus our reference angle. And you got 147.7 degrees. If they would not have said they wanted the obtuse angle, if they would have said they wanted the acute angle, you would have found this one. And you would have been done with a 32.3. But because they want the obtuse angle, the calculator doesn't know which one to find. It can only find us the reference angle, which is always going to be an acute angle in quadrant 1. Then we have to figure out what to do with it. And so this angle here is actually 147.7 degrees. Okay, because look, if I would have picked this angle here, let's just call it B, these would have been the included sides, which are the exact same as these two. So your calculator does not understand which one you're trying to find. Right, and then number 3 is doing that same thing with a triangle. The area is 3. There's 2 of the side lengths. The included angle is obtuse. And then find the measure of this angle. So I'm going to figure out what this multiplies to make. Divide that by 2. And I'll take 3 divided by 5.13. And I get that weird decimal. Then I want an inverse sine. And so I get the angle of C to be 35.8 degrees. But again, that would be an acute angle in quadrant 1. We want to know where else sine is positive, which is over here. So we're going to have to take 180 minus a reference angle to get the obtuse angle. And that gets 144.2 degrees. And that's it.